In this video, I will show you how to answer questions like these, given the graph of f or f prime. And I will show you how to justify your answers in a way that is clear, concise, and correct, just like the College Board wants. If you appreciate this content, please give it a like. Let's warm up with this question. Find a value of c for which the following statement is true. F of x is increasing and concave up at x equals c. Justify your answer. Make sure you have memorized the relationships between f, f prime, and f double prime. You should be able to draw this chart from memory on a piece of scratch paper in 30 seconds or less. On problems like this, I always like to write my justification first, and then work backwards and find the value of c that fits that justification. Notice that we are given the graph of f prime. That means our justification can only be based on f prime. We want f of x to be increasing, and we know that f will be increasing when f prime is positive. So far, I have x equals blank because f prime of x is positive. We also want f to be concave up, and we know that f will be concave up wherever f prime is increasing. So let's add that to our justification. So far we have x equals blank because f prime is positive and f prime is increasing at x equals blank. We can shorten this a little by saying x equals blank because f prime is positive and increasing at x equals blank. Now we just need to find a value of x where f prime is positive and increasing. F prime is positive and increasing on this part of the graph. And let's see, increasing, positive and increasing on this part of the graph. Including decimals, there are infinitely many correct answers. We can pick any number between -11 and -5 or greater than 13. For example, we can say x equals -7 because f prime of x is positive and increasing at x equals -7. Caution! I mentioned that your justification must always be based on the graph you're given, which in this case is f prime. But let me also emphasize that you must specifically name that function in your justification. You must avoid using vague phrases like because the curve is positive, or because the function is positive, or worse of all, because it is positive and increasing. You must be specific and say because f prime is positive and increasing. If you use any of these vague terms, you will not get the point. For the next few problems, we are given the graph of f, so all of our justifications must be based on f of x. Number 1, find an x-coordinate x equals c where f of c is greater than 0 and f prime at c is less than 0. Let's write our justification first and then go back and find the value of c that fits the justification. The first thing we are looking for is f at c is greater than 0. Well, remember we are given the graph of f, so we don't actually need to change this. We can just incorporate it directly into our justification. So I can just say x equals blank because f at blank is greater than 0. I don't have to change it. We also want f prime at c to be negative. F prime will be negative when f is decreasing. So we add on, and f of x is decreasing at x equals blank. Now let's find a value of x where f of x is positive and decreasing. F of x is positive anywhere above the x-axis, but we also need f of x to be decreasing. So f of x is also decreasing on this interval and this interval. So we just need to find a value of x in one of these two intervals. I'm going to go ahead and pick x equals -2. So one way you could write the answer is x equals -2 because f at -2 is greater than 0 and f of x is decreasing at x equals -2. Notice that I used two different formats in describing f of x. I used sort of a short way to say that f is positive, but I did a longer way to say that f is decreasing. You are not allowed to say f at -2 is decreasing. This is bad and will lose you the point. The reason is because f at -2 is a single number, and a single number cannot be decreasing. A single number can be positive, so that's why this is just fine. Having said that, I think it will be a little simpler if we rewrite this justification, combining the two. I think it sounds best to say x equals -2 because f of x is positive and decreasing at x equals -2. Number 2, find a value of c where f prime at c is equal to 0 and f double prime at c is positive. Our justification has to be based on f. We know that if f prime is equal to 0, then f has a horizontal tangent line. So x equals blank because f of x has a horizontal tangent line. By the way, you're not allowed to actually say HTL. I couldn't fit horizontal tangent line on my chart, so I put HTL, but this is not an accepted College Board abbreviation, so you're going to have to write it out. In addition, we need f double prime to be positive, but we have to link it back to f. F double prime will be positive, where f is concave up. So we add on, and f of x is concave up at x equals blank. I'm using this little abbreviation here because I'm running out of space. I think this is fine to use on the actual AP exam, but I'm going to say use abbreviations at your own risk. If you have the time and the space, I would actually write out all of these words. But to be clear, I think, for example, decreasing, if you write DEC, I think that's fine. You know, positive, negative. I think the College Board will accept this and this. And I think, you know, concave up with this little up arrow and concave down. I think the College Board will accept these things. But, you know, if you want to be 100% safe, write it out. Now let's look up at the graph and find where f of x has a horizontal tangent line and is concave up. F of x has horizontal tangent lines here, here, and here. But this is the only one where f of x is also concave up. We are told in the instructions that this horizontal tangent line is at x equals -0.5. Erasing the extra f of x, we say x equals -0.5 because f of x has a horizontal tangent line and is concave up at x equals -0.5. Number 3, find a value of c where f prime at c is undefined. We know that f prime will be undefined if the original function f has a discontinuity. That's like a jump, or it could be an asymptote, or even just simply a hole in the graph. If there are any discontinuities in f, then f prime will be undefined. But glancing at the graph, f is continuous. There are no discontinuities. But also we know that f prime will be undefined if f has a corner or a cusp. And we do see that at x equals 3, f has a corner. Therefore, f prime will be undefined at x equals 3. And that's it. X equals 3 because f of x has a corner at x equals 3. Number 4, find a value of c where f prime at c is negative and f double prime is positive. F prime will be negative when f is decreasing. So x equals blank because f of x is decreasing. Also, f double prime needs to be positive. F double prime will be positive when f is concave up. So x equals blank because f of x is decreasing and concave up at x equals blank. Now let's glance at the graph and find where f is decreasing and concave up. I've got a copy of the graph down here. So let's see. F is decreasing on this interval and this interval. The portion of this that is also concave up is this part right here. We don't know exactly what the point of inflection is where F changes from concave down to concave up, so let's not pick a point that's close to that transition point. Let's pick a point that's more definitely in this area. Let's pick -1. X equals -1 because f of x is decreasing and concave up at x equals -1. Number 5. F of x and f prime of x are both decreasing at x equals c. Our justification needs to be based on f of x, so we don't need to change this first part. We can just say x equals blank because f of x is decreasing. In addition, we need f prime to also be decreasing. F prime will be decreasing if f is concave down. Now we have x equals blank because f of x is decreasing and concave down at x equals blank. Let's scroll down and find a value of x where f of x is decreasing and concave down. F of x is decreasing on this interval and this interval. In addition, f of x is concave down on this interval and this interval. Again, we don't know exactly where the points of inflection are, so let's not pick a value of x that's close to where it seems to change concavity. I don't see any whole number that is safe. I would pick a value like -2.5. I feel like this is safely in the decreasing and concave down zone. It's even safer probably to pick a value in this tiny interval because we are specifically told that f has a horizontal tangent line at x equals 1.3. So we know that this value right here is at 1.3. So if we pick a value of x that is just a tiny bit to the right of 1.3, but super close so we don't get out of the concave down zone, then that'll be super safe. So I would pick a value like 1.4. X equals 1.4 because f of x is decreasing and concave down at x equals 1.4. Number 6. Find a value of c where f prime of x is negative and increasing. F prime will be negative when f is decreasing. So x equals blank because f of x is decreasing. F prime will be increasing when f is concave up. So x equals blank because f of x is decreasing and concave up at x equals blank. Let's look at the graph and find where f is decreasing and concave up. Again, f is decreasing on this interval and this interval. But in addition, f is concave up on this part of the graph right here, and that's it. So we have to pick a value in this little interval. And you know what? -1 is perfect. X equals -1 because f of x is decreasing and concave up at x equals -1. Looking back, let me emphasize two things that I've modeled for you on these first 6 problems. First of all, your justification must always be based on the graph that you are given. For the first 6 problems, we were given the graph of f, so as we scan down, notice that every single justification is based on f of x. F of x is positive, f of x has a horizontal tangent line, f of x has a corner, f of x is decreasing, f of x is decreasing, f of x is decreasing. It's all about f of x because that's the graph we were given. Nowhere did I mention f prime or f double prime after the word because. The other thing I wanted to emphasize is that I specifically named f of x in every justification. I did not use vague words like the curve is positive, or the function has a horizontal tangent line, or the graph has a corner, or worst of all, it is decreasing. Instead of using vague words like the curve, the graph, the function, or it, I always say f of x. You do the same. Numbers 7 and 14 are a different type of problem where you either sketch the graph of f prime given the graph of f, or you sketch the graph of g given the graph of g prime. I'm going to put these problems in their own video. If you're on a computer, you can click the link that appears in the upper right hand corner. Otherwise, you can find the link in the description. For the remaining problems, we are given the graph of g prime, so all of our justifications must be based on g prime. For number 8, we are looking for the x-coordinate where g prime is greater than 0. Since our justification has to be based on g prime and we are given g prime, we don't have to change this. We can just say x equals blank because g prime at blank is greater than 0. We just need to pick an x value where g prime is above the x-axis. Let's say 1, for example. There are many, but we can say x equals 1 because g prime at 1 is greater than 0. We are allowed to use the short way like this and say g prime at 1 is greater than 0 because this works fine for positive, negative, or 0. If you don't think you can remember when it's okay to use the short way, you can always use the long way and say because g prime of x is positive at x equals 1. For number 9, we need to find where g double prime is greater than 0. In other words, where g double prime is positive. Linking this back to g prime, we know that g double prime will be positive when g prime is increasing. Our answer will have the form x equals blank because g prime of x is increasing at x equals blank. We just need to pick a value of x where g prime is increasing. Good values to use would be x equals -4, 1, or positive 4. I'm going to pick x equals -4. So x equals -4 because g prime of x is increasing at x equals -4. For number 10, we need to find a value of x where g prime is equal to 0. Since we are given the graph of g prime, we don't need to change this. We can just look at g prime and see where g prime is equal to 0. For example, -4, -1, 0, 2, or 4. Let's pick 2. You can say x equals 2 because g prime at 2 equals 0. Or you can say it the slightly longer way and say because g prime of x is equal to 0 at x equals 2. But remember, we can use the short way when we are talking about a function that is less than 0, greater than 0, or equal to 0. For number 11, we need to find where g double prime is equal to 0. G double prime will equal 0 when g prime has a horizontal tangent line. Our answer will have the form x equals blank because g prime of x has a horizontal tangent line at x equals blank. Remember, you're not allowed to say HTL, so you're going to have to spell it out like this. G prime has horizontal tangent lines at -3, -0.5, and 1.3. I'm going to choose -3. So x equals -3 because g prime of x has a horizontal tangent line at x equals -3. For number 12, we need to find where g of x is increasing and concave down. Remember, our justifications must be based on g prime. G will be increasing when g prime is positive. We also need g to be concave down. G will be concave down when g prime is decreasing. So our answer will have the form x equals blank because g prime is positive and decreasing at x equals blank. G prime is positive on these portions of the graph that are above the x-axis. In addition, g prime is decreasing on this interval and this interval. So a good value to use would be -2. We say x equals -2 because g prime of x is positive and decreasing at x equals -2. For number 13, we need to find where g of x has a horizontal tangent line and is concave up. Linking back to g prime, g of x will have a horizontal tangent line when g prime is equal to 0. G of x will be concave up when g prime is increasing. So our answer will have the form x equals blank because g prime of x is equal to 0 and increasing at x equals blank. G prime is increasing on these intervals that I've highlighted. In addition, g prime is equal to 0 here, and here, and here. So any of these would be a good answer choice. I'm going to pick x equals 4. So x equals 4 because g prime of x is equal to 0 and increasing at x equals 4. Let me emphasize two important things which students often mess up. Since we were given the graph of g prime for all of these problems on the right-hand column, notice that all of our justifications were based on g prime. In every single case, it was because g prime was doing something. In addition, notice that I specifically named g prime. I was very careful to avoid using vague terms like the function, or the graph, or the curve, or it. Instead of saying because the curve is greater than 0, or instead of saying because the graph is increasing, or instead of saying because it is equal to 0, in each case I said g prime. Make sure you are always very specific and name the function on which you are basing your justification. Again, I'm going to do number 7 and 14 in their own video. You can find the link in the description. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.